So last time we were talking about mole and mole as a unit for amount of substance. We considered how we can convert mole from four different quantities back and forth into those quantities. We discussed that we can convert masses of elements, compounds into moles. We also discussed that we can convert volume of liquids and gases into moles. We discussed that we can convert number of uh, particles or species into moles. And we also discussed that we are going to consider how to convert concentration of a solution into moles and how these four quantities are commonly used in labs and in our daily life. And we need a unit that can convert them back and forth, one into another, so on and so forth. So we started off with just this kind of conversion here, and it was the only one that we did. Also, you can see the same heading that how we're going to convert masses into moles of substance and so on. So right after this one, we started trying to find how much mass would 1 mole of anything would have. We started off with oxygen. We found out that it is going to be a mass of 32 grams. We did the example of calcium chloride. We understood that 111 grams of calcium chloride would be 1 mole of calcium chloride. Then finally, we did it for identical sulfate crystals, PSO4.7H2O, and we found out that 278 grams of these crystals would be 1 mole of it. Then we understood the importance of quoting the formula. If we're going to do it with the help of a formula for moles, it would be easier for us. So we simply jumped on to the simpler calculations for moles with the help of the formula being number of moles for which the unit is mole itself. Without writing in E, this becomes a plural unit. The mass is taken in gram, the mass of 1 mole is taken in gram too, but instead mass of 1 mole, I told you that we're going to use the term molar mass. Molar mass is usually MR. It's just that MR having a different unit, gram per mole, is actually what molar mass is. So if the units are gram per mole and the value is exactly your MR, we can call it molar mass then. So we'll stick to the same term, however, mass of 1 mole. So you can see these three quantities in this formula. We converted those three quantities into a pyramid or triangle based factor in which we have the multiplication over here, and this line simply means division. Then there are three ways we can rearrange the formula. If we want to know the mass, we can multiply the number of moles with mass of 1 mole or simply MR of that substance, considering MR units would be gram per mole. If we have the mass and we have the mass for 1 mole, we can find out the number of moles by simply dividing them. This line means divide. Or if we need to find out the MR of a substance and we have the mass in grams, we have the number of moles, we can divide them. Again, the straight line means division. And we can find out the MR in the units of gram per mole, right? This mass of 1 mole means that if I put per mole at the bottom, it becomes molar mass. So we use these three formulas, and I told you that this formula is going to be the least one of your concerns. So since most of the time you will either be taking the number of moles, converting them into masses, this one, moles into masses, or you'll be converting masses into moles. So these formulas are the two that we are going to be using most of the time. So last time I gave you a couple of kind of questions. So let's practice a few more. For example, let's convert mass into moles. And let me tell you, this is the formula we are going to use for question one. So let's say in part one, you have 1.23 kilograms of sugar, the formula to which is C12H22, O22, not that, not O, H22. I'm saying it right, but writing it wrong. O11. There you go. So remember, I told you the practice. In order to get this formula right, we need to have the math, which we have in the question. We sometimes need a conversion. Remember, the math is always to be taken in grams. So the first thing you need to do is take this value of kilograms and convert it into grams. For this value, would definitely need the MR. You can calculate the MR from the formula that you have, and then you can simply divide these two values, the mass in grams and the MR. You'll get the value number of moles. So go ahead and try it right now. Your first part of conversion was that you took the mass of 1.23 kg, you multiplied it with 1,000, and you converted it into 1230 grams. Is that it? Your second
Yep.
part was to find the MR. You took that P12, 8, 22, or 11, and you multiplied it 12 with 12, and then 22 with 1. You can simply add 22 right there, and 11 with 16, and this was 144, this was 22, this was 176, the total coming out to be 342, right?
Yeah.
Remember, MR can be converted into molar mass if I write the units gram per mole. As soon as I do that, it's not MR anymore, it's mass of 1 mole of substance, or molar mass to be exact. All right. So
Yeah.
let's keep these units with MR every time we calculate an MR for this specific formula. Okay. And the final one was that your number of moles, and now I'm writing this exact formula, number of moles for the one which unit are mole itself. The mass was 1230 grams, and the molar mass was 342 gram per mole. And now you're gonna help me with this because this requires calculation. So yeah, answer came out to be
3.596. So if we round it, so it'll be 3.60.
3.59. Okay, so you can round it out to 3.60. But remember, there should at least be three significant figures in your answer. So 3.59 is a pretty good answer. You can write that. You can write a digit next to it too if you want to. That's totally up to you. Okay,
Yeah.
so yeah, well done. So that's great. Moving on, let's take another kind of question. I'm gonna erase the whole solution. And this time we are going to use the formula slightly differently with a rearrangement. So let's say our question number 2 is the exact opposite of question number 1. This time we're going to take moles and we're going to convert them into mass. All right. So let's say we have 0.001 mole of NaCl salt, and we need to convert it into kgs of it. Instead of grams, I'm changing it a little bit. You need to answer it in kilograms. So you can use the whole formula. This is the formula we're going to use for question 2. When you're done with it, at the end of it, you might need a conversion of grams back into kilograms. Go ahead.
Oh, we'll just divide it with 1,000, right?
Right. Divided by 1,000. You're good. So go on with it. Take your time. Let's get on with it. So you immediately applied the formula, and our formula this time is mass in grams is equal to moles. Whatever number of moles we have, and the unit is would be mole again, and you multiply it with MR. And in the case of NaCl, it's pretty simple. It's 43 plus 35.5. The answer comes out to be 58.5. So you have 0.001 mole. You multiply it with 58.5. Your answer comes out to be
0.058. 0.0585.
0.0585. Now, this is in grams. We need to divide it by 1,000 to get our answer, and probably your calculator says 5.85 into 10 raised to power minus 5
Mm-hmm.
um,
Yeah,
grams. Sorry, not grams, since we have
kg.
divided it, kilograms. Is that
Yeah,
right?
yeah.
Good, good. Now, here we go for notation. As soon as you go for notation, the three significant rules remains the same. So this is one, this is two, and this is these are three significant figures. Even if you're going with scientific notation, you are supposed to go with at least three significant figures. You may go with four, you may go with five. It's entirely up to you.
Mm-hmm.
All right. So
Yeah.
that's how we clear this up. These kind of questions, both the kind of questions. Now, I can really put on a question about number of moles and mass to find out the MR. I don't really have one in mind, so we'll do it when we'll do it with the rest of the questions for past papers. Now, we understood these parts. These questions are rather easier, which are given in the book. And the hints over here, they give us the idea that how we do not rely on uh, the simple calculations, and we emphasize for the formula, using the formula is much more safer than just doubling or tripling the values are. Okay, which brings us the basic work for today, the extension work. Now, this extension work really comes in papers, but that is definitely a part of past papers. Okay. In order to go with this, your book simply tells you just the number conversion. But what I'm going to do is that I'm going to leave you with a formula, like just like the previous one. So it's going to really help you with this conversion back and forth without a hassle. Because this right here is the concept, and you need to completely understand the concept and then apply it properly to different questions rather than having a formula is much more easier. Even if the student is slightly broken or misconcepted at points, applying the formula really helps them to get to the right answers. Well, we'll try for the correct concept first and the formula afterwards. So what does the concept say? The moles in Avogadro's constant. Avogadro's constant is actually a number. Avogadro is the name of the great scientist who came up with a number. Imagine you have 1 mole of carbon-12 isotope. Now, it would have a mass of exactly 12 grams, and it would contain a very large number of carbon atoms. Now, for you, it is almost impossible to calculate the number of carbon atoms. But the great thing about Avogadro's work is that he came up with the idea and he gave us the exact number of atoms for 1 mole of any substance. And that is 6 into 10 raised to power 23, which means 6 is followed by 23 not, which means that is a really huge number. So it's 6, 0, 0, 0, 0, and I write almost 23 zeros. This would be the number of atoms in 1 mole or just in 12 grams of carbon.
Mm-hmm.
So
Yeah.
that is a really big number. Now, 12 grams is almost half a tablespoon, the spoon we use to eat every day. That half a spoon consists of this many atoms. If I keep writing and I write 23 zeros, I don't know how many they are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are just 10 zeros. I actually need to write 23 zeros. So this would be the number of atoms. That's why we say atom is so small, surprisingly small, and there are so many atoms. Uh, Even the words like millions, billions, or trillions do not cover it, because I hope you understand that million has 6 zeros, right?
Mm.
If I use the word billion, it has 9 zeros. If I use the word trillion, it has 12 zeros. So really, these words don't cover it because it has 23 zeros. So you can say a trillion of a trillion or a little less than that. Okay. So this number 6 into 10 raised to power 23 is known as Avogadro's constant. 1 mole of anything on the planet contains the exact same number of particles. Now, if you're talking about 1 mole of atom-based substance or element, it would consist of this many atoms. If you're talking about water, now water is a covalent compound, so it would consist this many molecules. If I talk about any another thing, let's say I am talking about magnesium. Magnesium is an element. So elements are made up of atoms. So I am going to write it as atom, right? H2O. Now H2O is a covalent compound, right? So it would consist this many number of not atoms, molecules, because covalent compounds are then uh, converted into smaller molecules. Now, if I use this, now this is an ionic compound, this is not a covalent compound. So the word really changes. We say formula unit because it has a big lattice. I can't use the word molecules with it. If I talk about simple ions, now these are ions. This is not even a compound. So I have to really use the word ions. So this becomes a set of four different words. It's really difficult for students as starters to convert them or give them a proper name. So what do? We don't use these words, atoms, molecules, formula units, or ions. What do? We use a bigger, broader term, particles. This is the word with which you are never going to be wrong, right?
Yeah.
Because these words are too difficult for a student to remember. So a bigger, broader term, how many particles in present are in something. So if you use this word, you will never be wrong. Another good way of understanding which word to use is to look out for the word given in the question. Sometimes the examiners put the exact word you require in the question, so students don't have a problem. They can really replace the word particles with the word given in the question. Let's say they are talking about iron metal, so the word needed to be used is atoms. So examiner would give you this word exactly there in the question statement. But if you're confused, instead of using this, use this. This is more like a safe word. You're never going to be wrong with particles because all of these are actually types of particles. Okay. So this is the number of particles in 1 mole of a substance. For 1 mole of magnesium, that would be 24 grams of magnesium. For 1 mole of water, that would be 18 grams of water. For 1 mole of NaCl, we have just calculated it. That is 58.5 grams of NaCl. For 1 mole of SO4 ions, sulfur is 32, oxygen are 4 atoms, so it's 16 into 4. This would be 32 plus 64 is equal to 96. So 96 grams of this would be this many ions. So I hope you understand that each and every single one of them have different masses, yet they are just 1 mole of a compound. That's why 1 mole is such a good unit that it clarifies for anything that have different masses. And again, Avogadro's constant is again a great unit because the number of particles is the same for all of these substances, though they are weighing differently. And that's the main concept behind mole and Avogadro's constant. These values do not change. 1 mole of anything may weigh the different. Why? Because atoms weigh different. Magnesium weighs differently than hydrogen or oxygen or sodium or chlorine or sulfur. So that's why they have different masses, but yet in terms of moles or in terms of Avogadro's constant, the units or numbers are same. Now, this whole thing seems like a bit of a difficult concept for conversion for students. So what we come up with is that we give them a very easy formula. Again, you can convert number of moles. Now again, the unit would be mole into number of particles. And since this is a number, an exact count, this one does not have a unit. Divided by Avogadro's constant. And remember, Avogadro's constant has a unit of per mole. Why? Because this constant has the very definition that this is the number of particles in 1 mole of a substance. They are very specific about it. one mole of anything consists of the same number of particles, right? So that's how this formula works. Shall we do a couple of questions about this formula to make sure that you understand this one in specific?
Yeah.
Now, the great part about this formula is that the denominator is every time going to be 6 into 10 raised to power 23. That's the denominator because the denominator says Avogadro's constant, and Avogadro's constant is this exact same number every time. So we can literally either convert number of particles into number of moles or number of moles back into number of particles. All right.
Yeah.
So question number one, convert number of particles to moles. Question one, what if you have 1.2 into 10 raised to power 25 molecules of water? Then how many moles do you have? Now the idea is really simple. This time you do not need to calculate MR. This time you don't even need the formula. You're simply going to take this number and divide it by 6 into 10 raised to power 23. That's how easy it is going to be. Go ahead and try it. Great, 20. So I hope your answer is 20 moles because you literally use the formula number of moles and the unit would be mole itself is equal to number of particles, which now we have 1.2 into 10 raised to power 25, and we divided it by 6 into 10 raised to power 23. Now, the modern calculators can work it really well if you write this number and then you put the divided sign and then you write this number. But if you have an old calculator, I really suggest my students to put brackets and then write the divide symbol and then write brackets around it. That way, you're never going to get your answer wrong. And this one, of course, has the unit of mole inverse over here, and your answer comes out to be 20 mole. Now, this is 20 mole of water. Now, once you have moles, you can go for an extended practice. All right.
Mhm.
Maybe your examiner asks you to answer the question with mass and grams of water directly. Then you need two formulas. You need the previous formula as well, of course. You use this formula, you take the answer out in moles. You know how to use the previous formula to convert these moles into mass? Can you? Remember the
Yeah.
formula was mass in grams was equal to number of moles into MR if MR is taken in gram per mole. And the unit for this one is mole, so let's write over here. So apply the formula, get the mass.
Mhm. So we should find the MR water, right? So
Yes,
it's
MR of water, H2O, which we memorized it to be 18.
18.
Remember, we have been doing it for so long that we memorized the MR for water.
Sir, the answer is 360.
The answer is 360 grams. So perfect. So you took this 20, you multiplied it by 18, and your answer came out to be 360 grams of water. All right. Are we
Yeah.
good?
Yeah.
Great. So this gives you the idea how to convert number of particles into moles. And then if your examiner asks for the further extent and more work around the question, he may directly ask you to convert number of particles into mass. If that happens, don't worry. First use one formula get your answer to moles, and then convert moles into anything, which gives us the idea. Remember, if your question 2 seems to be too difficult or impossible, you don't have any direct formula for it. Remember, the first thing needs to be converted into moles, and then moles are supposed to be converted into this. So if you think there is no formula to convert molecules directly into masses, yes, there isn't a single formula. What do? You convert molecules into moles and then moles into mass. That's how moles is a great unit. And chemists know how to convert even the something that might apparently seem impossible into possible, right? You see
Mhm.
that you converted it first into number of moles, and then you took those moles and converted into mass, which may have seemed impossible if I directly ask you the question of converting molecules into mass. All right. So
Yeah.
let's erase the bottom part of it, and let's go with another question before we finalize today's class. Okay, that was water. Okay. The question number 2 is again the rearrangement of the same formula. You convert the moles to number of particles. And remember, if you know which particle type is that, whether they are atoms, molecules, ions, or formula units, you can really write that. But if you don't know, or if you're even in a little bit of doubt, do not risk it. Use the term particles because that's a very safe term. You will never be wrong. Okay. So
Yeah.
part one, let's say we have 1250 moles of MgSO4.7H2O. Now, I may write a horrifying formula over here, but remember, this is a moles and number of particles question. You do not need to worry about MR. So you really don't need the periodic table to solve this question. Go ahead and take your time to convert moles into particles. Remember, this time we're going to rearrange the formula. In order to find number of particles, you take the number of moles and you multiply them with the Avogadro's constant. All right. So what is your answer?
7.5 into 10 to the power 26 grams.
No, this is number. There won't be any unit. It's not
Oh,
math.
yeah. Yeah.
Okay. So I hope you used the formula. You took number of moles and you multiplied them with Avogadro's constant. All right. So what you really did right there, just a second, what you did that right there was 1250 multiplied with 6 into 10 raised to power 23. So can you repeat your answer?
7.5 into 10 to the power 26.
7.5 into 10 raised to power 26. What you're going to do to make sure that the three significant figure answer is that you write 7.50.
Mhm.
A very important point. So if you have two figures, add the zero end of it to make sure, if it consists of decimal, of course, to make sure that there are three significant figures in your answer. So 7.50 into 10 is about 26. And just to make sure that you're not cutting short on a unit, write the word particles next to it. So the examiner would know that you're talking about particles.
Mhm. All right.
All right. So I
Yeah.
hope we are good with both the kinds of questions with this formula as well. If you mention the formula in the paper, that's okay. If you don't even mention the formula, just simply use it in the paper. It's also good too. Sometimes sometimes what the examiners do, and this is the very last type of question I'm going to talk about right now. Okay, so I am going to erase a few parts of it just to make sure I have ample space for the kind of question I'm going to put forward. Okay, so the third thing they commonly do is that calculate number of atoms present in 10 moles of water. Now, this time he was very precise. Now, you know water is a covalent compound. It consists of molecules. So when you're going to go with this question, what students tend to do is that they simply go with this formula. You need to find number of particles. So number of particles would be equal to taking the number of moles given in the question, 10, and multiplying it with the Avogadro's number, right? And you will have a very simple answer, 6.00. I'm really adding 00 to make sure that this actually becomes three significant figures. So this becomes molecules of water, all right? Now here the concept is actually needed. You can't just go with this formula and get to the correct answer. He's talking about number of atoms, not molecules. Now you need to really look at the formula. The formula consists of a total of three atoms, two of hydrogen, one of oxygen. So you need to really multiply three with your answer, right? So this would become 18 into 24, or you can really convert 24. If you are going to do it on the calculator, you would notice it would be 1.80 into 10 raised to power 25 atoms as a whole. We're not specifying any specific kind of atoms. The total number of atoms would be this. Why? Because there would be two atoms of hydrogen and one atom of oxygen per molecule of water. If he's being specific, so number of H atoms, then you do not need to multiply this P. The number of H atoms is your 2 multiplied with your answer, like this. They're really 12 into 10 raised to power 24 H atoms, right? And number of O oxygen atoms. Number of O atoms would be the same as your answer because that's really 1 multiplied by 6 into 10 raised to power 24, which is 6 into 10 raised to power 24, right? Now these are O atoms. And if you sum these up, right, this one and this one, 12 into 10 raised to power 24 and add 6 into 10 raised to power 24, you'd see that your answer comes out to be 1.8 into 10 raised to power 25 atoms. So yeah, if you multiply 3 directly, or if you multiply it with two ones and one ones and add them together, it's the exact same number of atoms. I hope you get the whole idea or the picture now. The same thing is done on YouTube with circles as atoms or diagrammatically, which is much easier to understand for students sometimes rather than just going with numbers written over here in the form of text. So if you get the idea, well and good. If you don't get the idea, I would definitely recommend you to watch a YouTube video about moles in Avogadro's constant, especially the ones that consist of animation to give an idea how we take the number of particles, especially the molecules, into simpler atoms, and you would understand how this whole thing goes. If you understand it by text, well and good, but if your imagination can't work up to that far, so you definitely need a video for it. What do you say? Do you need a video or is it understandable without a video?
So I only did not understand why. Okay, so we are converting into atoms again, right? Because it's there
Right,
in the question.
right. Because a molecule is definitely made up of atoms. So we can bifurcate between a specific number of molecules. These are the number of molecules we have. But if you need to step down and break them into number of atoms you have, you can go for the whole process. Either you can do this whole process, or instead of doing the whole process, you can simply work out how many atoms are there in the formula and you can multiply it with your number and you'll get your answer. All right.
Yeah.
If you're good with this, fine. If you think you can't work your way around it, or you can't imagine the whole thing, you can't picture it in your mind, search the same terms, moles as and the Avogadro's constant. You may put the word Edexcel next to it, and you can go for a few YouTube videos, and those animations are going to work great to give you a proper picture for your mind, or give you a mind map on how this works. All right. Even I can recommend you a couple of those if you can't find it on your own. Well, the student must know how to search on YouTube. After a couple of failures, you definitely land on the correct video.
Mm-hmm.
Okay. And I think this is good enough for the day. Do you agree? For example, we're not working with water. For example, we are working with sugar. In sugar, we have 12 of carbon, 22 of hydrogen, 11 of oxygen particles. Now, if the examiner specifically asks about hydrogen, right, you need to take this number and you need to multiply this number with your answer. Let's suppose our answer is the same. Our answer is this, right? So you'll get the number of H atoms. Okay.
Mm-hmm.
But if he asks you the total number of particles, obviously you need to add these. So for the total, you have 12 hydrogen, you have, 12 carbon, 22 hydrogen, and 11 other particles. So definitely you have, I guess, what, 33, 44, and 45. So you have a total of 45 particles. So you multiply 45 into 6 into 10 raised to power 24, and you will have total number of particles. So it's really up to the examiner which specific atom he asks about, or he asks about total number of atoms. If he asks about total number of atoms, add these numbers, the numbers written as subscript at the bottom. If he asks
Mm-hmm.
about any specific type, take that number and multiply it with your answer. It's really that simple. Specific particle, use the subscript and multiply it with your answer. All number of atoms, add all of the subscripts, and then multiply that number with your answer. You will get total number of atoms. So it's really up to the examiner what question he asks, and you can really put your concept right there, and that's how the concept works. I hope now it is more understandable. Now it makes more sense, right?
Yeah.
Did you hear that?